Hello, boys and girls. This is Mrs. Wen Gervasio, and today we'll be covering Chapter 3, Lesson 3.1, Algebraic Expressions. Reference pages to this lesson could be found in our Google Classroom under or titled 3.1, pages 82 and 83. And this is where you can find the textbook pages to the lesson that I'm covering today. As a reminder, if I am going too fast or something doesn't make sense in this video lesson, feel free to pause it and press play again. Let's go ahead and continue. Okay, so in our first example we have here is we're going to identify terms and like terms. As a reminder, a term is any variable that you see. So if you see a variable, that's a term. It could be also any variable with a number. That's also a term. And it could also be a simple number as a constant. That's also a term. And the other ones are just the same. So if we count our terms, they're usually separated by a operation. So let me go ahead and separate the operations so you can see. They're separated by operations. So we're going to count our terms here. We see that we have 1, 2, 3, 4, 5 terms. But there are some terms that are like terms. So what we're going to do is I'm going to go ahead and underline all the like terms for you. So this one is like terms with this one because why? They both have the x as a common variable, and so they share what I call the same last name. First name is 4 here, last name is x. First name is 1, you don't see it, but there's an invisible, last name is x. They both have the same last name of x, so therefore they are like terms. Now this negative 3x, they also is a like term with the other two terms here that I underlined. Why? Because they all share the x as their like terms. Now, the number that you see here that I'm going to put a dot on, 6 and 1, they are like terms. They belong to a different family because now they are a number family. So these are like terms. So as you can see, terms are separated by operations. So we have 4, and then like terms are anything that they share same common variables with. So, or they can just be numbers. Okay, let's go ahead and do an example below so you can see and get a better understanding of what terms and like terms are. So I'm going to go ahead and solve A. A says to find the term and like term. So what we're going to do is I'm going to find the term. So the term, I'll put T for term. The terms we have here are going to be 9x, negative 2, 7, and x. So the terms will be 4. Now the like terms are going to be, I'll put LT, like terms are going to be which ones? I'll go ahead and circle them, or I'll put a dot on. 9x is a like term with negative x. So why? Because they both share the same variable of x. So I'll put 9x and negative x. The other reason why the other ones don't have the like terms as 9x and negative x is because they don't have an x. They belong to a number family. So we'll put another color. Negative 2 and 7. They belong to another like term family. As you can see, these are all numbers, constants. These are variable x and variable x's. Now for B, the terms that we have here in B, let's go ahead and count them. We have z squared, we have 5z, we have negative 3z squared, and z. We also have 4. We also have 4 terms, but our like terms, let's see how many like terms we have here. Our like terms will be z squared, not 5z, because 5z does not have a square, but negative 3z does have a square. So z squared, and that's how I do my z, is going to be 1. Negative 3z squared is going to be another one. Now this one does not belong to the z squared family as well because they don't have a square. So we'll go ahead and start a new family of terms. This will be the 5z and the z. Those two belong to the same family. Why? Because they both have just the z's, no squares. Can you guys all see? This one has z's only, and this one has z squared. So those are our terms, 1, 2, 3, 4. And then the like terms will be the ones that share the same variable with the same power. Same variable, same power. Same variable, same power. Okay, Let's go ahead and try another example. Example 2. Okay, so now that we know what terms are and like terms are, what we're going to do is we're going to simplify it. What does it mean to simplify? Make simpler. Make it a little bit less complicated. So we're going to make this long algebraic expression into a shorter problem. So what we're going to do is we're going to combine them. Now, we first need to see if they all have the same last name, same variable. I see a u here, a u here, and a u here. So we're good to go in combining it. If they don't have the same variable, then you can't combine them. But since they do, we are going to combine them. So we'll combine them by these two first. Again, you can't do three at a time, so we're going to do them in order of operations, left to right. And it says here 8u plus 5u. It's like saying 8 umbrellas plus 5 umbrellas. What's 8 umbrellas plus 5 umbrellas? So that's 13 umbrellas, so 13u. And then how did I know that I was going to add? Because the operation that was in the middle right here tells me I'm going to add. Now, this right here is a minus, or you can say a negative 7u. So what I'm going to do is all I'm going to do is bring it down. So I'm going to bring it down. I'll show you right here. Bring it down. And when I bring it down, that says negative or minus 7u. And all this says is 13u, or 13 umbrellas, minus 7u, or 7 umbrellas. So what's 13 minus 7? 13 minus 7 is going to be 6. And then we have here the u, so you need to carry that u. And that's your final answer. This is a lot simpler than this. Do you see? Okay, so now let's go ahead and try one more example. I don't have it here, so I'm going to go ahead and add it on here. We have here 6d, and then we have here minus 5. We have minus 4d, and then we have here plus 6 right there. So which ones do they have in common that we can combine first? So first, let's see what they have in common. I see that the 6d here is in common with the 4d. And then I see that the 5 here shares this in common with this number. Because number to number, variables to variables. So what we're going to do is I'm going to go ahead and combine these two first. So it says 6, and then I look at this. What's in front of that? That says a minus, so it's going to be 6d minus 4d. What's 6d minus 4d? So we're going to go ahead and solve this. 6 minus 4. I know 6 minus 4 is 2, so then we have here 2d. Now what we're going to do with the numbers is what we're going to do is solve them on the side. We have here negative 5, that's a negative, and that's a plus, or we can say positive 6, so we can say negative 5 plus 6. What's a negative 5 plus 6? A negative 5 plus 6, the signs are different, so I'm going to subtract. 6 minus 5 is 1. Carry the sign to the larger, that is a positive. Now, since this is a positive 1, all I need to do is put that here, and we have 2d plus 1. That is simplifying the problem above. And that makes this a lot simpler right here to have than to solve that long problem. So this would be the short version. Okay, in our next example, what we're going to do now, or I'm sorry, not the next example. In our next slide here, I have here 6 problems for you to try on your own. Please take out a separate sheet of paper, and these will be your homework problems that you're going to try on your own. Um, try your best to do all of them, okay? And if there's for some reason you don't understand a problem, please make a note of it, and you can ask me questions tomorrow in class. So go ahead and pause the video and go ahead and try these problems. This is just exactly what I explained in example 1 and example 2. Okay, so now that you tried example 1 and example 2, we're going to go ahead and go to example 3. It's the same idea as example 2, but in this time, we're going to have to distribute. Now, as a reminder of the distributed property, what that means is if you have a number 3 and then you have 4x plus 5 and then plus 1, the 3 gets distributed means multiplied by the 4x. The 3 gets distributed, that means multiplied by the 5. Now, if it's not in the parentheses, you don't distribute that. So that means this parentheses is, or this number is not in the parentheses, you don't distribute that. So let's take a look at this example we have right here. We have 1, negative 1/2 times 6n plus 4. You don't distribute that last number because it's not inside the parentheses, so it would look like this. 1/2 times 6, negative 1/2 times 6n, negative half times 4. Now, anytime you multiply a half by a number, it just simply means cut that number in half. So what's half of 6? That's 3. What's a negative times a positive? Because that's a negative 1/2 times a positive 6. Isn't that a negative times a positive negative? Then you have negative 3n. What's a negative times a positive? That's a negative. So what's a half times 4? A half of 4 is 2. Now, since I don't distribute this last number, what do I do with it? I just simply bring it down. So I have here a plus 2n. Now what we're going to do right here is we're going to combine the like terms. Again, we're trying to simplify this problem. It means we're going to try to make it simpler. So what we're going to do is we're going to take the negative 3n and we're going to see if we have any common like terms that we can combine them. And I see a 2n here, so they share this in common. So negative 3n plus 2n. What's a negative 3n plus 2n? That's a plus. Oops, plus. So negative 3 plus 2, I know the signs are different. Negative 3 plus 2 is a negative 1, and all I need to do is bring down my n. And then since this 2 has no other numbers to combine, we're just going to bring the negative 2n, or negative 2 down. And there's my answer. Now, this answer I wanted to point out is the same also as this answer, negative n minus 2. Why is that? You don't necessarily have to have that negative 1 in the front. The book doesn't often use that, so I'm going to say this answer is a better answer. Okay? All right. So now that you have some examples of that, go ahead and try problem 7, 8, and 9, continuing on the same page that you started off with the problems 1 through 6 on your own. And go ahead and try them on your own. If you have any questions, feel free to ask me tomorrow in class. So pause the video and go ahead and try these examples. So you're up to 9 problems for homework right now. Okay, example 4 is a real life example. So I'm going to go ahead and have you read this, follow along with me as I read out loud this story problem. Each person in a group buys a ticket, a medium drink, buys a ticket, a medium drink, and a large popcorn. So medium drink, large popcorn. Write an expression in simplest form that represents the amount of money the group spends at the movies. Interpret the expression. So imagine that you and your group of friends are going out to the movies and you want to know how much is it going to cost for your whole group of friends to go to the movies. Well, first of all, you need to know how much is the ticket. The ticket costs $7.50, so it says $7.50 for the ticket. And after that, it says that you and your group of friends each are going to drink a medium drink. So our medium drink is $2.75. So $2.75. And then it says each of your friends are going to also want to buy a large popcorn. I guess you guys all like popcorn, so we're going to get a large popcorn of $4. Now, if we add this total up, let's see how much this total is going to add up. We're going to go ahead and calculate that really quick, and that comes out to be $14.25. Now, that doesn't necessarily mean that's how much it's going to cost for you and your group of friends to spend. That's just for one person. So if you want to know the cost of the whole group of friends, do you know how many friends are going to attend? If you don't know how many group of friends that are going to attend, what you can do is, or how many friends are going to attend, you're going to add an x to each one of these, okay? And since you're adding an x to all of this, you just add an x here also. That indicates the number of people that's going to be part of your group. Do you know how many? You don't. So if you were to figure out for 3 groups of friends, so we'll take 1425 x, 3 groups of friends would be 3 friends and 1425. And then what you do is you would just multiply the 1425 by the 3 groups of friends. So how much would you spend? If you know the answer, you can tell me tomorrow. Okay. Go ahead and answer number 10 on your own. Go ahead and pause the video and answer this question. Jot down any questions you may have. And this goes on the same page as your other on your own. So by now, for your homework, you should have 10 problems all on the same page. So on your own will be your homework all on the same page. Okay. Now, on the back of your on your own, or somewhere at the bottom, if you still have space, you're going to go ahead and answer this question. This is your exit ticket. So this is in addition to the 10 problems, you should have 10 problems and these 2 questions answer. So go ahead and pause the video and write down your answers, and we'll go ahead and talk about these 10 questions and questions A and B here tomorrow. All right, for tomorrow, I will need for you to have your questions ready. any notes you took from the video and the homework on your own from this video, as well as the exit ticket. So these two are the homework pages that I expect to see in class tomorrow. And then the completed wrap journal that we did today in class needs to be completed and turned in. So these are the three things with the checks that I will be collecting tomorrow. Again, please come prepared, ready with your questions, and have a great day. I will see you tomorrow.